Hello juniors, today we're going to see electronic assignment number 5, which is applications of right angle triangle trigonometry. We're going to see real life applications of triangles basically, okay? So 2 objectives for today's class. Number 1, find the length of a side of a right angle triangle, and find the measure of angles on right angle triangle. Basically the same thing we have been covering in the last class, but now we're going to apply these concepts to real life scenarios. And we're also going to discuss about 2 different concepts which involve angles, okay? So it says the angle of elevation is the angle up from the horizontal, while the angle of depression is the angle down from the horizontal. Whenever you see these terms, angle of elevation or of depression, you should automatically think about this situation, okay? Where the angle of elevation, as it says, if we have a point here, another point here, we draw a horizontal line, right? And the angle of elevation would be the angle that is formed above that horizontal line, while the angle of depression is the angle formed below that horizontal line, okay? So that's a concept for you to consider. Let's see an example of this. It says, Rondo is flying a kite. The kite string is at an angle of elevation of 60 degrees. If Rondo is standing 30 meters from the point on the ground directly above the kite, find the length of the kite string. Okay, so let's use this sketch here in order to solve this problem. The first thing we have is that there's an angle of elevation of 60 degrees. That means that if we trace a horizontal line right here, maybe like this, then this angle over here, the one above the horizontal, is the angle of elevation, right? Which is 60 degrees. And we know that Rondo is standing 30 meters apart from the point on the ground directly below the kite. That means that this length over here is the one that is worth 30 meters, right? That's the distance we're given in this problem. So 30 meters right here. So you see that here we can form a right triangle. 90-degree triangle, and we can solve this triangle to find the length of the kite string, which is exactly the hypotenuse of this triangle, okay? So that's what we need to do. We need to find the hypotenuse of this triangle. I'm going to call this x, for example. So how can we find the value of x in this case? I see that, for example, you have the angle here, and we have the adjacent side of this angle, and I'm looking for the hypotenuse. So if you remember SOHCAHTOA, from SOHCAHTOA, you should identify that we need to apply, in this case, cosine, right? Because we have the adjacent and we have the hypotenuse. So I'm going to say that cosine of 60 degrees is equal to adjacent, which is 30, divided by hypotenuse, which is x in this case. Okay, so if we solve for x, we're going to have that x is equal to 30 divided by cosine of 60. If we use the hand trick in order to determine cosine of 60, you remember that cosine of 60 is equal to a square root of 1 over 2, which is 1/2, right? So without using a calculator, we can say that this is 30 divided by 1/2. Cosine of 60 is 1/2. So if we solve this, we're going to get the value of x. This is the same as saying 30 times 2, so 30 times 2 is 60 meters. That means that the length of the kite string is equal to 60 meters. Okay, that's it for this problem. It's easy, right? Let's see another example. It says, an observer standing on the top of a vertical cliff 120 meters above sea level sees a ship in the water at an angle of depression of 9 degrees. How far is the ship from the base of the cliff? Okay, so the best way to solve this problem is to first draw a sketch of the situation, right? We're talking about a cliff, right? So let's do a vertical line here. This would be the water where the boat is. Let's say the boat is right at this point, for example. And we know that the cliff is 120 meters above sea level. So if this is the sea, so if this line is the sea, then 120 meters would be this height over here. So 120 meters above sea level and angle of depression. Okay, so now we need to think about this data. Angle of depression. Remember that the angle of depression is always given with respect to a horizontal line. So let me do a horizontal line here, just a second. If I draw a horizontal line right here, then the angle of depression is with respect to that horizontal line. So if I trace a line which is below that horizontal line, then the angle of depression would be this angle over here, okay? That's the angle of depression. So this is 9 degrees according to our problem. And, well, if you see in this, we have a right triangle here. The red triangle is a right angle triangle. And if this is 9 degrees, you should already know that this angle over here is also 90 degrees. Why? Because this line over here is parallel to this line over here, and they share the same line here, the oblique one. So that means that this angle is the same as this angle. This is called alternos internos in Spanish. Ángulos alternos internos. So, sorry, I saw that I wrote 90 here. You should actually say 9 degrees, okay? So it's the same angle formed up here. So there we have. Now we have the triangle ready to solve, right? What do we want to find? How far is the ship from the base of the cliff? So basically we're trying to find this side over here. So I'm going to call this side again X, and we're going to solve this. Again, I see that we can apply SOHCAHTOA in this case because we're talking about a right angle triangle. So we're looking for this side, and we have this side, and we have this angle. So it's more convenient to use tangent in this case, right? Opposite over adjacent. So I'm going to write tangent of 9 degrees is equal to opposite, which is 120, divided by x, which is what we're looking for. So x is equal to 120 divided by tangent of 9 degrees. In this case, we will have to use calculator. We cannot use our hand to do the trick because 9 degrees is not a special angle, right? So if we use a calculator, remember your calculator must be set up in degrees. So you plug in the information, 120 divided by tangent of 9, and you will get the result. This is 757.7 if we want to round it. Or maybe if we round it to 3 significant figures, it's just 758. 758, we're talking about meters in this case. So that is the result. That's the distance from the base of the cliff to the boat, to the ship. Okay, so this is easy peasy. Now let's move on to another concept of angles. It says, the 4 cardinal compass points are north, south, east, west. If you remember, north, I'm going to do a compass here. It's north, south, east, west. Okay, that's for you to remember. So there's one way to represent angles using compass points, and another way which is known as 3-figure bearings. It says 3-figure bearings give directions as angles measured clockwise from north. We're going to see what that means in a second. Okay, so for the first case, using compass points, this is how we interpret angles. It says, when using compass points for direction, you will see notation such as north 40 degrees east means 40 degrees east of north. Basically, the rule is to follow this direction first and then 40 degrees to this direction, to the second direction right there. So for example, north 40 east means that I first go north, and from this direction I would go 40 degrees to the east, right? To the east, which is to the right. So 40 degrees, and here I have the final direction of this problem, right? So you first follow this direction, you measure this angle, and then you follow this direction. Or you end up in that direction, basically. So for example, west 20 degrees south, we first go west, right? And as we want to go south, we need to go 20 degrees down, right? So 20 degrees down, and here we have the final direction that we're heading to, right? Finally, for this example, northwest, it says. So we go north, and then we go west. And since we do not have an angle, it means that the angle formed is the same as if I were to go west and then north, right? So we assume that when we're not given an angle, it's 45 degrees, as it is right here, right? 45 degrees between north and west. Then we have the other rule, which is a little bit more tricky. It says, When using bearings for direction, you will see a notation such as this. And you have 0, 35 degrees, or just 35 degrees, right? What does this mean? This means 35 degrees clockwise from north. So whenever you read the word bearings, or you're given an angle in this form, or this form, or this form, you should follow the same rule always. It's you always begin from north, okay? So you go north, and then you go 35 degrees in this case, clockwise, okay? It's always clockwise. You see the definition here. Clockwise from north. Remember that rule. So 35 degrees, a bearing of 35 degrees means that I go first north, always north, and then 35 degrees clockwise until I get to this position. So this is the direction of a bearing of 35 degrees, okay? Then for this case, a bearing of 110 degrees, we go, as always, we go north, and from this direction we go 110 degrees, and when we end up with the angle, we trace this final direction, which represents a bearing of 110 degrees, right? Finally, for this case, 270, we do the same thing. We start from north always, we trace 270 degree angle, and where we end up is our final direction. In this case, a bearing of 270 degrees is the same as saying going to the west, okay? So I hope this is clear for you people. Let's see some examples. It says, let me read this first. 270 degrees means 270 degrees clockwise from north. Notice that the bearing of 270 is the same as due west. Okay, so it's what I just explained. Let's see this example. It says, Nina runs 5 kilometers on a bearing of 120 degrees from the start. How far south has she traveled? Okay, so let's make a sketch of the situation in order to understand what's happening here. First of all, we're going to draw our north, or we're going to draw the whole thing, right? North, south, east, west. East, west, right here. I'll make it a little bit bigger. There, okay? So, from north, we always start from north, right? So, from north, I'm going to do this in a different color. I'm going to use black for this. Here. So from north, we want to go 120 degrees clockwise, right? So we trace our north first, and then we see 120 degrees. This is 90 up to there. So we need to go a little bit more, maybe up to there, right? So this direction over here represents a bearing of 120 degrees, okay? That's how we work with bearings. Okay, so this is the direction that Nina is following, right? So she runs 5 kilometers on that direction. So that means that this arrow over here is 5 kilometers long. Then it says, how far south has she traveled? So if you see this sketch done here, you can realize that I can form a right triangle here, right? I can complete this triangle. Let me use this right here and right here. This is a right triangle. A right triangle. Let me change this again. This is a right triangle, right? Where if this is 90 degrees, then the remaining angle right here would be 30 degrees, right? So let me trace this as 30 degrees. So there we have. We want to find this value over here. Why? Because it says, how far south has she traveled? So this distance over here it represents the distance that she traveled south. So there we have the triangle that we need to solve. We want to find the opposite. We have the hypotenuse, so I can apply SOHCAHTOA. And in this case, we're going to apply sine, right? Because it's opposite over hypotenuse. So sine of 30 degrees is equal to opposite, which is x, over hypotenuse, which is 5. Okay? So the value of x would be 5 times sine of 30. If we use in this case, we can use our hand, right, to determine sine of 30 because 30 degrees is a special angle. If you remember, sine of 30 is, again, 1/2, right? So this would be 5 times 1/2, which is equal to 5 divided by 2, right? Or we could just leave it as 5 divided by 2 is 2.5 kilometers. That means that Nina traveled 2.5 kilometers south. Okay? So I hope this is clear. Let's do, I think we have two last examples, and then we're done. It says, a boat travels on a bearing of north 36 degrees west for 25 kilometers. So now we're given the angle in this format, okay? So we need to, first of all, do a sketch in order to see what's happening. We're traveling north 36 degrees west. So north, and from this direction we go, let me do this in black. From this direction we go 36 degrees west, right? So 36 degrees, and maybe somewhere around here we would have our final direction, which is, now I need to do this in red. This would be 36 degrees to the west, right? To the west means to the left, right? So this is our final direction over here. So it says, a boat travels on a bearing, we have already drawn this bearing, for 25 kilometers. So this is worth 25 kilometers. Sorry, 25 kilometers. Okay. So it says, how many miles north has the boat traveled? And then for part B, how many miles west has the boat traveled? So basically, you would see that if I complete this right triangle here, right here, and right here, we know that this distance over here, I'm going to call this x, is the distance traveled north by the boat, and this distance over here is the distance traveled west by the boat. Okay, so we need to find both values of y and x. So to find these values, this is a right triangle, I can apply SOHCAHTOA, right? SOHCAHTOA. So to find, for example, the value of x, which is what we want to find for part A, the miles traveled north, I can apply a cosine, right? We can say that cosine of 36 is equal to adjacent, which is x, over hypotenuse, which is 25. So if I solve for x, we're going to get that x is equal to 25 times cosine of 36. In this case, we will need to use our calculator because we cannot calculate cosine of 36 with the hand. So 25 times cosine of 36, this gives us a value of 20.2, if we round this to 3 significant figures, kilometers. So this is the distance traveled north. And to find, for part B, the distance traveled west, we're going to do the same thing, but now we're going to apply, instead of cosine, we need to apply sine, right? Because we're finding the opposite side. So this would be sine of 36 degrees is equal to opposite, which is y, over hypotenuse, which is 25. Let me change this a little bit. Y over 25. Here. So if we solve for y, we're going to get that y is equal to 25 times sine of 36 degrees. We solve this using calculator, 25 times sine of 36, and we get a value of 14.7 kilometers if we round these to three significant figures. So this is the distance traveled west by the boat. Okay, so it's easy, right? Whenever you do the sketch first, these types of problems become much easier. Now let's see this last one. It says, a boat is due north of a lighthouse and sails on a bearing of 292 degrees for 51 kilometers until it is due west of the lighthouse. How far is it from the lighthouse now? Okay, so we need to really understand what's happening here in order to make us a sketch that will help us solve this problem. Okay, so let's read it again. A boat is due south of a lighthouse and sails on a bearing of 292 degrees for 51 kilometers. Okay, so let me do a sketch here. We're going to say that the lighthouse is for example, this point over here, lighthouse, and the boat is due south initially, right? So maybe somewhere around here, we have the boat, right? Lighthouse and boat. Okay, then it says, the boat is traveling on a bearing of 292 degrees. So if let me do this in black. When we're given in this format, remember we should always begin north and then do our bearing, right? So from north, we're gonna go, if I do the whole coordinate, I'll take the B down here, there. Remember it's, we go north first, and from north we go, this is 90 degrees, then this is 180 degrees, then this would be 270 degrees. So we need to go a little bit up, a little bit, so maybe somewhere around there would be 292 degrees. So all of this angle marked here is 292 degrees. But we're only interested in this final position, which is this one over here, right? So this is where the boat is traveling, and I'm going to extend this until it is west, maybe somewhere like there, right? Because it says until it is due west of the lighthouse. So you see that here, where I stopped, is exactly due west of the lighthouse, right? So you see that we're getting a right triangle right here, which is the one that is going to be useful to solve this problem. Okay, so this is a right triangle, and this is the direction where the boat is heading. Okay, so if all of this in black is 292 degrees, then how much should this angle right here be? Well, it's easy to calculate, right? We know that the whole circle is 360, so 360 minus 292 would give us this angle, which is 68 degrees. 68 degrees. Okay, so it says, how far away is it from the lighthouse now? So basically what we're trying to find is this distance over here. The distance from the boat after it sailed 51 kilometers, the distance to the lighthouse, right? So there we have the sketch. Once you've done this, you see that it's quite easy to solve, right? If we apply again SOHCAHTOA, we're going to say that we're looking for this distance, right? So we would need to apply sine, right? Sine of 68 degrees is equal to opposite, which is x, over hypotenuse, which is 51. So we solve for x, 51 times sine of 68, and we get the value. We use calculator for this, times sine of 68, and we get the distance, which is 47.3 kilometers. So this is the final distance, okay? So I hope this is clear for you, juniors. It's easy, right? If you do the sketch first and you understand what the problem is talking about and you do a correct sketch, then solving the problem is very easy, right? But you need to practice this in order to be able to dominate the sketching part, which is the toughest part to solve, okay? And for that, you're going to be practicing with exercises, which I'm going to be assigning in the following days, okay? So I hope this was clear. If not, please let me know, and we'll cover it out in future live sessions. Thank you for your attention, and see you.